Implicit memory is one of my favorite subjects. It's the sort of memory that sort of rises to the occasion without your intending to actively remember something. So here are the strict definitions. Explicit memories are things that are consciously recollected. For example, recalling a vacation or a specific time, series of events, etc. An implicit memory, it's not deliberate or conscious, but shows evidence of prior learning and storage and rises to the occasion to help you do something. For example, you might be separated from riding a bike for decades, and then as soon as you get on that bike, are able to ride it, as the saying goes, that's a procedural memory. That's a subdivision of implicit memory, but they can get sort of cognitive in nature too. And I'll give you one example here just in a second that's really fascinating. Here's a separation of an explicit versus implicit memory. Do lab demonstrations of implicit memory have any real-world relevance? Investigators who study implicit memory believe that they do. One example, this is an anecdote, reported by Korsakoff, who in 1889 described patients with an amnesic symptoms that have come to be known as Korsakoff's syndrome. One patient to whom he had administered a shock professed not to remember the shock, but on seeing the case containing the generator, told Korsakoff that he feared the scientist had probably come to electrocute him. So there was no apparent explicit memory, but he had retained some sense of danger, which is implicit. I want to show you a classic experiment that demonstrates this. You can see as the pictures progress from bottom right to top left, it begins to fill in. Let's take the umbrella. On the bottom right, the umbrella is badly degraded. By the time you get to the top left, it's full. So it is the case with the bed. Young participants, as young as 4, let's say they studied the umbrella among other objects, but did not study the bed. They come back the next day. They would identify the umbrella earlier in the progression, maybe 3rd from bottom left, but they maybe couldn't identify the bed then until the 6th or the 7th drawing, and it needed to be filled in more. The suggestion is having studied the umbrella brings it to memory easier, brings it to perception easier, and implicit memory. There's no conscious effort to recall the umbrella or to recognize it, but it jumps off the page easier at an earlier stage of degradation than the bed, where the bed needs to be filled in more because it had not been studied. That's the idea of an implicit memory, and a very clever task by Parkin and Street from 1988, which is fairly clever. So in implicit tasks, also, this is interesting, sort of a separation of amnesic and control patients. In implicit tasks, amnesic and control participants guessed incomplete or degraded words, as we just saw those degraded pictures. In explicit tasks, asked to recall or recognize the words. And here's what the figure will show here in a second. Figure 6.2 presents the results. This is straight from your text. It shows quite clearly that amnesic participants performed more poorly than non-amnesic participants on the explicit tasks. In other words, those with amnesia did worse on things that are explicit, as we might expect. In other words, their amnesia seemed, but on the other hand, I should clarify this sentence, but they performed quite comparably or adequately compared to non-amnesic participants on the implicit memory task. And here they are. And this graph is out of your text. Basically, on explicit tasks on the top, the 2 top boxes, the amnesics were worse on recall and recognition. And you remember that difference from our previous videos. On the implicit tests, such as identifying word fragments or completing word stems based on words that had been seen before, they did nearly as well. And in fact, in the bottom left there, they did slightly better than the persons that did not have amnesia. So it may be the case that you have 2 different memory mechanisms for implicit versus explicit memory. Amnesics are, of course, much worse on explicit things that they need to recall or recognize. But when things can leap to mind without their being actively tried to be remembered, in that case, they're almost comparable with people that don't have amnesia. So one possibility, as I mentioned, is that there is a different memory system. Another is that the two kinds of memory tasks require different cognitive procedures, although they both tap into a common memory system. And that's Roediger, the guy that did the testing research. One idea consistent with this proposal is that most implicit memory tasks require some perceptual processing, and that explicit memory tasks require the processing of concepts. In this view, the type of processing required in the two types of tasks explains this dissociation. Much debate focuses on the question of whether the two approaches can be reconciled, and essentially this debate hinges on whether there are multiple and distinct systems of memory, each operating on different principles, or a single system that supports different kind of processing. So it's not exactly resolved here in the current day, but I hope you recognize in this graph the difference, what an implicit memory task is. And these word fragment identifications and word stem completions don't rely on explicit memory. They sort of leap to help you do a task, as was the case with these youngsters identifying the umbrella in the bed. But in that case, the amnesics performed just as well as the controls, the people that don't have amnesia.